Now we look at an example of problems involving concentration units. Example 1, a 6.25 m of sodium hydroxide solution has a density of 1.33 gram per milliliter at 20 degrees Celsius. Calculate concentration of NaOH in molarity, mole fraction, and percent by mass. Okay, so they want us to calculate the molarity, mole fraction, and percent by mass. Okay, so before I proceed, I would like to remind you about the units involving all the parameters. Okay, for molarity, the unit will be gram per milliliter. Sorry. For molarity is mole per liter, or we can say mole per dm cube. For molality is mole per kg, or molal, or small m. Okay, that stands for molality. Molarity also we can use capital M. Percentage by mass, because the gram and gram of mass can be cancelled, so it is only in percentage. Mole fraction is dimensionless. That means no unit, right? No unit, Percentage by volume, milliliter, or liter can be cancelled. So this answer will be in percentage. Okay, those are the units. So based on this, if we look at 6.25, the info given, number one, they said 6.25 m. The small m refers to molality. So we define molality, moles of solute divided by mass of solvent, and I have 6.25 molal. Okay, that is the first info. The second info is the density. The first info was 6.25. The second info is the density, or I should highlight better. If I highlight better, okay, 6.25, density 1.33. So we go to the density. Density, I think most of you know, you have learned in secondary school. Density is mass divided by volume. Okay, in this case is given as 1.33 gram per milliliter. Okay, and of course they mention here is the density of the solution. So that means here we denote this is a density of solution. That means the mass should be mass of solution, volumes will be volume of solution. Okay, and temperature is not important over here, temperature, because this is under concentration, does not involve temperature. So these are the info we have, and the first question they ask us to find, the question is molarity of NaOH. So I write here molarity of sodium hydroxide. That means mole of solute divided by volume of solution in 1 liter. In 1 liter. Okay. So before we proceed with the solution, we also have to identify who is the solute, who is the solvent, and who is the solution. Okay, solute, normally the compound given in the question. In this case, sodium hydroxide is the compound given. Solvent, they never mention anything, so it's a universal solvent called water. And you add these two together, you add both together, you get sodium hydroxide aqueous. So this is the solution. Okay, All right, now we try to solve this question. So I have to find the mole of solute. And this is my question. I have to find under the info. So mole of solute we find from here. Right? This is where the mole of solute can be found. Eh? That is where you find the mole of solute. How about the volume of solution? Volume of solution, meanwhile, volume of solution can be found from here. Okay, that's where you can find the volume of solution. All right, but if you, let's say I want to solve the mole of solute, I need to know the mass of solvent. Okay, however, if you remember in my previous video, I already said molality defined as mole of solute dissolved in 1 kg of solvent. So the mass of solvent is 1 kg or 1000 gram. So this is known from the definition. Eh? That means if I take molality, if I take molality, mole of solute divided by mass of solvent, which is 6.25 molal or mole per kg. We can use mole per kg, we can use mole per kg, or we can use molal, or we can use small m. So I convert the small m into mole per kg. Excuse me. So I convert that in mole per kg. Now I substitute the values. Mole of solute divided by 1000 gram, or okay, we use kg lah, easier. We use just 1 kg. 1 kg based on definition equals to 6.25 mole per kg. That means mole of solute equals to kg can be cancelled. So I get 6.25 mole. This is the mole of solute. So we go back to this question. That means we managed to solve this mole of solute. How about volume of solution? Our second thing. To find the volume of solution, I need to know the mass of solution. Okay. In this case, we know the mass of solvent as 1 kg or 1000 gram. So we can come to this formula. Mass of solution sama dengan mass of solute tambah mass of solvent. So this is another formula. Okay. So mass of solution equals to mass of solute. Mass of solution equals to mass of solute plus mass of solvent. So we find the mass of solute first. Mass of solute we only know the mole of solute. So that means we want to find the mass, mole times molar mass. Mole is 6.25 mole. Molar mass, we are talking about solute. Who is the solute? Our solute is sodium hydroxide. Molar mass of sodium hydroxide is 40 gram per mole. Students can find this, right? Molar mass of sodium hydroxide is 40 gram per mole. Sodium is 23 plus oxygen is 16 plus hydrogen is 1. That gives you 40. Okay. So this is 40. Unit for molar mass, gram per mole. So mole can be cancelled off. Therefore, I can get 6.25 times 40. I get 250 gram. This is the mass of solute. Then we go to the mass of solvent. Mass of solvent is already known, 1000 gram. How do I know? We already find from here. Therefore, mass of solution equals to 250 plus 1000, that is 1250 gram. That is mass of solution. So we take this mass of solution, we get this mass of solution, and we substitute over here. We substitute here, mass of solution. So I rewrite here, density of solution equals to mass of solution divided by volume of solution equals to 1.33 gram per milliliter. Mass of solution 1250 gram. Volume of solution unknown, right? Unknown. And this is 1.33 gram per milliliter. So gram can be cancelled. Therefore, volume of solution, we have to find 1250 divided by 1.33. 1250 divided by 1.33. I get 939.8. 939.8 milliliter. You can see here, milliliter. So if I change it to liter, that is divide by 1000, I get 0.940 liter. Okay, therefore, finally, we have solved our volume of solution as well. Then molarity can be solved. So the final molarity equals to moles of solute divided by volume of solution. Moles of solute, where do I find the moles of solute? 6.25 mole. 6.25 mole. Volume of solution 0.940 liter. Then the molarity is 6.25 divided by this, I get 6.65 mole per liter. This is the molarity. The first question.